Well, hello everyone. Thanks for taking the time to stop by here. I just had a nice lunch, settle in, and relax a little bit, or get up and move around, get that sugar circulating. My name is Daniel Fisher. I work at the ARS in Stoneville, Mississippi. I'll talk a little bit, the big picture, kind of about irrigation scheduling, and then Mr. Loren Green is a producer, crop consultant from just down the road in Greenwood, Mississippi. He'll tell you about his experiences and how he's using sensors to manage his water resources. And there's the yellow envelope, or the folder back there if anyone needs it. So first of all, irrigation scheduling, sometimes when I've mentioned this to people, there's a misconception about what I mean. So I thought I'd start out by telling you more or less what I'm talking about. Irrigation scheduling is just using some type of information to decide when you need to irrigate. It's nothing complicated, doesn't have to take a whole lot of time. It's just trying to use more information to make a better decision. So there are a lot of methods that people have used over the years. Many of them are pretty subjective, looking at the crop, looking at the soil, irrigating on a calendar every week. So there are many other methods that are available, but there's been minimal adoption of these more objective scientific methods. I'll talk about a couple of those. So as we know, this is a conservation conference. We know the value of water. We need to do a better job working with our water. There's changes in crops, changes in the seasons, uncertainty about weather and rainfall. So we need to recognize water for what it is, a valuable resource. So agriculture is a pretty complex operation, complex system. We're only looking at one small part of it, the water. But there's still a lot going on with just the water. The water needs vary for different crops. You can see these water use curves here on the right. They're different. They're very different for the different crops. The water use varies throughout the season, and it varies from season to season based on whatever the weather is. So we need to use it efficiently, get the water to the crops when they need it to maintain yield and profitability. A little bit is good, so more is better. And a lot of times that's the case, but only up to a point. You can add more water and get more yield, but you reach a point where the yield is stabilized. Anything more you add to that, you're going to be doing damage to the crop and losing money. So we need to find that maximum, that optimum point. So there's a lot of different technologies that people can use, more scientific, more objective methods. I've broken these into two main categories, some software methods and hardware methods. The software methods are basically crop and water balance models. These are based on weather and some crop characteristics. A lot of different states and a lot of different regions, they've developed their own water balance models or methods. Some of these you download the model and put it on your computer. More are going to internet-based, and there's some that are coming to your smartphone. Hardware methods, these are basically sensors. A lot of different types of sensors are available, sensors and instrumentation. These days there's a lot more wireless and cellular data transfer, trying to make it easier to get the data out of the field, cut down on the hassle, and get more people to adopt this by making it easier. And then there's some irrigation system components that you can modify or work with to try to improve the system that you've already got. I'll start out with the water balance models. There's advantages and disadvantages. The main advantage, it's pretty cheap to use. Download some software or you go on the internet. The information that you get from it is often relevant over a larger area. The weather is pretty constant in a broad area. So what you find in one place may be of use in another place if you've got some fields that are far apart. The disadvantages, though, these models theoretical or empirical models. They're just mathematical equations. We're trying to estimate what's going on in the real world with some equations. And sometimes these models, you need to input some information that you really may not have a good feel for. You have to estimate some of these parameters. So the idea behind these water balance models is that water is moving in and out of the soil constantly. We want to try and monitor where this water is going. So monitor the main components, the water that's leaving, the water that's coming in. So these models are oftentimes called checkbook models. Just like your checkbook, you keep track of what's going out, what's going in, make sure you have a balance that's sufficient to take care of your needs. So the water use varies throughout the year, throughout the season. Early in the season, the crops may be using 1/10 of an inch a day. So after a week, that's barely half an inch of water. We usually get a lot of rain, enough rain early in the season. But in the peak part of the season, you might be using 1/4 of an inch, 3/10 of an inch. So after a week, that's 2 inches of water. You need to make sure that, if you haven't gotten 2 inches of rain, do you have it in the soil, or do you need to irrigate? And this is a simple water balance model. It's just a checkbook. If you want to know what your situation is today, look at what it was yesterday, add in any irrigation you applied, or rainfall, subtract out what the crop used, and then update your balance. So you enter some basic weather information into your model, it'll do the calculations, and then update your soil water deficit. So you'd follow this red line throughout the season, and when it got down to some allowable level, that's when you need to irrigate. So the sensor-based methods, again, this is good and bad. One of the advantages is you get some detailed site-specific information. When you install the sensors in your field, you know what's going on in that field. You can automate these, and then you get detailed information over the season. The disadvantages: it costs money to buy these, put them in, maintain them. But what is an advantage is also a disadvantage, the site-specific aspect. If you put sensors in here, you know what's going on here, but you may not know what's going on in a different part of your field or another field, so the information is very localized. So some of the issues dealing with sensors: well, what type of sensor do you want to use? What type of instrumentation is this going to need? How many sensors do you put in a location? How many sites do you have? How do you decide where those sites are? And these depend on a lot of different factors. One of them, expense. You can spend a little money, you can spend a lot of money. How much is this worth to you? And then some of the other decisions are going to be based on your particular situation, your field, the variability in your field. Can you get to the sites if you need to? So first, how many sensors do you need? I think the extension people, the consensus is you need at least 2 anytime you put some out, preferably 3. A sensor near the surface, because if you look and see how the roots are growing, there's a lot of root activity near the surface, especially early in the season. And then you'd want a sensor deeper down, where the most active root activity is, and then a deeper one. See if you're getting enough water deeper down, or this also gives you an indication of your root growth. If you put a sensor down deep, you can see if the roots are going down there, and they may be taking advantage of some water deeper down. And then, how do you decide where to put them? So if we had a field like this, and there's some variability in the field, we have our poly pipe here and we're irrigating, how do you decide which part of that field do you put your sensors in? And there's some different ideas that people have, different recommendations that are made. You might want to put them in your low water holding capacity soils, the parts of the fields that dry out first, because those are the ones that are going to need irrigating first. But then if you do that, what about the other parts of the field? Are you putting too much water onto those? Well, another idea, the predominant soil type. If you've got an area of the field, a larger area, that's where the majority of your crop is, shouldn't you pay attention to that part? But then again, what's going on in the rest of your field? Based it on yield potential. You've got a part of the field that does really well. That's where you're making some money. You want to pay attention to that part of the field. But again, what's going on in the rest of the field? So I think if you've got some different areas in your field, you need to monitor those different areas. Get the most information you can, see what goes on in those different areas, and then you can get a better idea of where you should be paying attention to. What you need, which one of those are you going to be basing your decisions on? But ideally, if you've got some variability, you've got different parts of your field, it would be better if you could manage those parts of the field individually. So if you know you've got distinct areas of the field, can you treat those as separate fields and take care of those individually, manage each section individually? So if you might mean you need to modify your irrigation system, it's going to take some more management if you have to manage 3 areas instead of 1. But the idea is to maximize your yield, maximize your profit. So now about the sensors. I really can't say much about sensors because there's so much to say about the sensors. There's so many different types of sensors that measure a whole range of things. If you go over here to the trade show, you'll see a couple different sensor people. There's a whole lot more than these guys. There's so many different types of sensors that measure so many different things. You have to decide, what's going to work for you. Talk with other people, see what has worked for them. We don't have enough time to talk about all the different sensors here. And then along with the sensors, there's the data collection and the transmission options. In the olden days, you'd go out there in the field with a meter, and read. You'd have to go to each site and make a manual measurement. That's too much work. Nowadays, there's a lot more radios, mesh networks to get the data out of the field. And the next step is cellular. Take the data from the field, send it to a computer, send it to a website. Anything we can do to make it more convenient for you, and you're more likely to use it. So data access, some people prefer to go out there in the field, push a button, look at a screen, and see what's going on in the field. They can look at the crop, look at their sensors. Other people, I'd rather look at it on the internet, make some decisions here, and then go out and see if I need to. Then go out and look at the field. So another thing that a lot of people think is irrigation scheduling. Okay, I need to use this in real time to schedule, to decide what I'm doing today or tomorrow. And a lot of people do it that way. You put these sensors out, you take measurements, or you run your models, and you base your irrigation decisions on the model or the sensors. But that requires a lot of flexibility in your production operations, your irrigation system, the ability to decide today, I need to go out tomorrow. Another way to use this technology is what I call passive monitoring. You put the equipment out in the field, you check measurements throughout the season, but you go about your normal operations. Do your irrigations the way you normally do it, because you don't intentionally make bad decisions. You're trying to make the best decisions. So monitor, put the equipment out in the field, monitor throughout the season, and then at the end of the season, you go back and look and see how you did. In this case here, we were following these sensors. This is the sensors, this is the model. We were watching these sensors. It doesn't look like we need to irrigate here. This is our allowable limit here. It shows the same thing here. This is our allowable limit. This was our water balance. It looked like we had some time, but we decided to irrigate. And then a couple days later, it rained. Or later on, here we irrigated again. Our sensors showed we were getting close. Our model said, yeah, we need to irrigate. So the second irrigation, I think we did pretty good. This first one looks like we didn't really need that. We irrigated a little early. If we hadn't irrigated, we would have saved that irrigation. And then a little bit about some irrigation system components you may be already be using. The faucet, the pipe planner, a more scientific way to decide how big your holes need to be. And if you've got irregular fields, this can really help out. Everybody needs a rain gauge. A lot of times it'll pour at my place. When I go out to the field, I didn't get nearly as much as I thought we did. A flow meter, you're using the water, you're paying for the water. Do you know how much water you're using? Are you putting enough water out? Are you putting too much out? Do you need to make some changes to your irrigation system? You don't know if you don't measure it. And then a surge flow valve. A way to automate your irrigation system, reduce deep percolation, get the water moving across the field a lot faster. So some of this simple technology here has nothing to do with scheduling, but it'll still help you with your operations. So conclusions, water's a good thing. We need to conserve it. There are a lot of tools available that can help us see if we need to do a better job. Many times, people know what they're doing. We've been doing this for years, for generations. You know what's going on. But sometimes it's a good idea to get some tools and just check and see if you can make some improvements. So these are valuable resources. We need to use them as efficiently as we can. So I know some of the people here like to heckle. There's my email address. You can heckle me all you want. Or if you have some other questions or comments, I'll try to help you out if I can. And now the real reason you came. Mr. Loren Green is going to tell you how it's done in the real world.
I got a question for you. I've been trying to get some surge valves and some flow meters help from the USDA, and I have signed up for that, and I have had the hardest time getting a response. And I know the money's there.
Should I run down the government, or is that what you were trying to do?
That's what I was trying to get. Or have you been working with any of those programs with
I work for
cost
the-
share to producers?
I work for the ARS, Agricultural Research Service. It sounds a lot more like NRCS.
That is, I'm sorry, my mistake.
And I know those programs vary in different regions. So you have to speak with the NRC in your region and see exactly what they're willing to, what kind of programs they support. And Mr. Green.
Any more questions for him?
If there's any questions, you'll have the answers.
Hi, I'm Loren Green, and I'm a consultant and farmer in the Mississippi Delta.